We'll start with a smaller example, a clock with 3 numbers from 0 to 2. One of the hands I'll label H and the other one will be M. This will correspond to a location on a lattice point labeled here as P. P has H equal to 1, which means it's pointing to the number 1 on the clock face, and M equal to 2, which means the M hand is pointing to 2. Since the hands can move only clockwise, from point P, the minute hand can move to the right to point Q over here where M is equal to 0, which I'll note like this. If the hour hand moves clockwise, we can move from P to this point R, where H is equal to 2. Since our hands can only travel clockwise, then the paths can only go up or to the right between lattice points if the hour hand moves or the minute hand moves. Since every possible position of the hands appears exactly once, in our lattice point diagram, that means every lattice point will appear one time on a path. Here are some examples of what that would look like. A lattice point can have a minute hand advance to it, and then the hour hand moves, or a minute hand moves to create a position, and then it moves on to the next hand position, or we can have something like this. What is not allowed is we cannot have two inputs going into the same hand position, nor can we have something like this where we move from a lattice point in two different directions, because a lattice point will appear only one time on a path, giving us a unique hand positioning on the clock. We can use this to illustrate some restrictions that we have on the movement through the lattice points. So for example, if we begin at lattice point labeled P, and then the minute hand moves so that we end up at lattice point Q. If we look up here at lattice point labeled S, since our paths can only go up and to the right, we already have a path that passes through lattice point P and moves to the right. We can't have two outputs coming out of lattice point P, so we can't go from P to S, which means the path through S must have originated from this point R. Likewise, if you look at this lattice point T, from T we can't move the hour hand because that will take us back to Q, and we've already seen this hand positioning. This means that when our hand positioning is at lattice point T, we can only then proceed by moving the minute hand and going from T to U. We have a similar situation if going from P to Q means moving the hour hand. We're going to have what looks like parallel paths through the lattice points in our grid. So let's see what that means for a clock face with 6 numbers. So we have a clock that looks something like this from 0 to 5, and we have minute hands that can hit any of these numbers, and the same with the hour hand. We'll begin with both hands pointing up at 0, 0, and we'll start by moving the minute hand to 1 on the clock face. Since our path goes from 0, 0 to 1, 0, it can't go up to 0, 1. So the path to get to 0, 1 has to have come from the left. And since this is a clock face, it actually comes from this point at 5, 1. We'll continue this pattern of parallel paths that are determined by the first movement. From the top, we continue down at the bottom where we started. Let's say our next clock face movement is our hour hand. So the hour hand is going to go from 0 to 1, which means we have determined all the rest of these parallel paths from 1 to 2 and 2 to 3 and so on. This one at the top continues down at the bottom. We have 36 lattice points here. So as we construct our path, we think about 6 parallel pathways consisting of 6 lattice points each, and then repeating that in a parallel fashion. We notice that when we create these horizontal pathways, 1, 2, 3, 4, 5, 6, we have 6 of them, and likewise 6 of these vertical pathways. Starting at the origin, we already have a horizontal M and a vertical H. So let's just pick a path consisting of 6 lattice points. So let's just do MH, MM, HH, and then we'll fill in the parallel paths. I'll do that here. The first thing I notice, when I start from the origin, I have MH, MM, HH, and then here I'm going to repeat this sequence. MH, MM, which continues over here, and then H, which continues at the bottom. Takes me back to the origin, and I clearly haven't filled in all of the lattice points. Let's fill in the rest of these paths and see if we can figure out what's going on. Here are our 6 parallel paths with the starting points marked in orange. MH, MM, HH. Here we have MH, MM, H continues down at the bottom, and another H, and so on. If we start at the origin, we'll first go along this parallel path, then we'll continue up here at 0, 4, then go up and resume down here. Let's figure out why we skipped so many parallel paths by following the location of the starts of our 6 pathway sequences. We start where h is equal to 0, and because this sequence has 3 h's in it, we add 3 to our vertical coordinate, and we end up here at h equals 3. When we run through this sequence of 6 paths again, we're going to end up at h equals 6, which is equivalent to 0, and down at the bottom. We see that because 3 divides 6, if we continue this, we're just going to go through these 2 pathways over and over again. So it looks like, because our clock has 6 numbers on it, our initial sequence of 6 paths cannot be divided into m's and h's in such a way that the number of m's and the number of h's divide 6. To verify this, let's try it again. And in our first sequence of 6, let's let the minute hand move just once, and the hour hand will move 5 times. So we'll pick maybe this sequence. Minute hand, and then the hour hand moves 5 times after that. And we'll repeat this sequence of 6 paths. Starting at the origin, we'll go horizontal and then vertical 5 times. And then we'll repeat M, and then H takes us back down to the bottom. And again, in parallel, we'll move horizontally and up 5 times, continuing down here. As I draw in these paths, I can see that this is probably going to be a winner because I haven't returned to the origin yet until now when I filled in all the lattice points. Let's trace our path from the origin. This will be our first path, and then we'll continue down here at the bottom. And again, we continue down here. Path 5 resumes over here at number 6, where we end up back where we started. We see that with each sequence of 6 moves, we add 1 to our value of m. So starting at the origin, m equals 0, and after one sequence of 6, m goes to 1, and so on until we're back to m equals 0 again. This seems to work for n equals 6, so let's return to our problem where we have 12 numbers on our clock, generating a 12 by 12 grid of lattice points that we need to traverse. This means we're going to have 12 repeating sequences of 12 parallel paths, but we want the number of horizontal or vertical paths to be relatively prime to 12. Again, if it isn't, say we have the number of times that the minute hand moves is 3, then we're going to start at the origin where m equals 0. After 12 moves through our lattice point, m is going to be equal to 3, and then after another 12, 6, and 9, and then 12, which puts us back at the origin without having traversed all of the lattice points. The numbers that are relatively prime to 12 are 1, 5, 7, and 11. For example, if the number of minute hand movements is 1, the number of hour hand movements is 11. The number of sequences of 12 that contain 1 minute hand movement and 11 hour hand movements is 12 choose 1. So the total number of sequences for all of these values of m is 12 choose 1, 12 choose 5, 12 choose 7, and 12 choose 11. In Mod 1000, this is 608. If you'd like me to solve any other contest problems, please leave them in the comments.